What if one small molecule could change the way we think about fat metabolism? Welcome back to the Baka'z lab. Before we get started, this is not medical advice. I'm not telling anybody what to take, how to take it, or what to buy. This series is for education, research, and documenting my own learning journey. Always talk to a licensed medical professional before using anything that affects your body, metabolism, hormones, or health. Now today, we're talking about one of the most searched but least explained compounds in this whole space, 5-amino-1-MQ. And first thing first, this is important. 5-amino-1-MQ is not technically a peptide. A peptide is made from amino acids linked together, but 5-amino-1-MQ is different. It's a small molecule compound. More specifically, it's usually described as an NNMT inhibitor. So even though people group it with peptides because it's sold in the same research space, it's not actually a peptide. That's why this episode matters, because a lot of people are looking for information, but the information out there is limited, confusing, or just straight copy and paste. 5-amino-1-MQ stands for 5-amino-1-methylquinolinium. The main thing people talk about with 5-amino is its effect on an enzyme called NNMT. NNMT stands for nicotinamide N-methyltransferase. Now don't let that big name lose you. Think of NNMT like a metabolic switch. When NNMT activity is high, especially in fat tissue, it may affect how the body handles energy, fat storage, and certain nutrients connected to NAD plus metabolism. So the theory behind 5-amino-1-MQ is simple. If NNMT is overactive, blocking or reducing that activity may help the body shift toward better metabolic function. That's why people are interested in it for fat loss, energy metabolism, body recomposition, and metabolic health. But here's the honest part. Most of the strong research is still animal research, cell research, and early stage metabolic research. So we have to separate the science from the hype. The proposed mechanism is that 5-amino-1-MQ inhibits NNMT. NNMT uses nicotinamide, which is a form of vitamin B3, in a process connected to methylation and NAD plus metabolism. NAD plus is important because your cells use it for energy production, mitochondrial function, repair processes, and metabolism. So when people say 5-amino may support fat loss, they're usually talking about this pathway. NNMT inhibition may preserve more nicotinamide, which may support NAD plus related metabolism, which may help shift fat cells away from storage and more toward energy use. That's the theory. In animal studies, NNMT inhibition has been linked with reduced fat mass, improved metabolic markers, and changes in white adipose tissue. But again, animal results do not automatically mean the same thing happens in humans. That's why I'm careful with this one. Yeah. People are interested in 5-amino-1-MQ for a few main reasons. Number one, fat metabolism. This is the big one. Most people find 5-amino while searching for stubborn fat, belly fat, metabolic slowdown, or weight loss plateaus. Number two, NAD plus connection. Because NNMT interacts with nicotinamide metabolism, people connect 5-amino with NAD plus support. That makes it interesting for people already studying NAD plus, NMN, NR, MOT, CSS31, or mitochondrial health. Number three, body recomposition. Some people are not just trying to lose scale weight, they want better energy, better training output, less fat storage, and a leaner look. Number four, it's different. This is not a GLP-1 like Reta. It's not a repair peptide like BPC-157. It's not a mitochondrial peptide like MOTC or SS31. 5-amino's in its own lane. It's more of a metabolic research compound. A lot of people compare 5-amino to Reta, but they work very differently. Reta works by targeting hormones that help regulate appetite and blood sugar. 5-amino doesn't work that way. Instead, it's believed to inhibit an enzyme called NNMT, which plays a role in how your body stores and uses fat. Think of it like this: Reta helps control appetite. 5-amino is being researched for how it may improve fat metabolism. They are both studied for weight management, but they take completely different approaches. The injectable version is usually seen in research vial form. This is why people sometimes think it's a peptide, because it looks like the same setup: vial, reconstitution, research labeling, and storage instructions. But again, the form does not make it a peptide. A compound can be injectable and still not be a peptide. The oral version is usually seen as capsules, tablets, or powder. A lot of people prefer oral because it feels easier and less intimidating. No needles, no mixing, no reconstitution. But with oral compounds, the big question is always absorption. How much survives digestion? How much actually gets into circulation? How consistent is it from product to product? With injectable, the question becomes different. Is it sterile? Was it produced correctly? Is the concentration accurate? Was it tested? Is it actually what the label says? That's why quality and testing matter so much in this space. Oral may be more convenient, injectable may be marketed as more direct, but neither version should be treated casually. This is still a research compound, not an FDA-approved weight loss medication. They work through completely different pathways. Because human research is limited, we don't have a complete side effect profile. Some people online report changes in energy or appetite, but those are personal experiences, not scientific proof. More human research is still needed. One reason 5-amino has become so popular is because it's different. It's not a GLP-1, it's not a peptide, it's a small molecule that targets metabolism in a completely different way, and that's why researchers are paying attention. So that's 5-amino-1-MQ, not a peptide, but a small molecule NNMT inhibitor available in both oral and injectable forms. The research is promising, but most of it is still preclinical, so there's still a lot to learn. I'm Baka'z Man, and this has been the Playground Lab. I'll see you in the next experiment.